Very good day, students. This recording is on process design that we did last week, right? Um, yeah. So, without further wasting time, I want to make the video short as possible. For those that were not able to attend, this is an opportunity to follow what we did in class. So this session recording will prepare you for the test that you'll be writing next week Monday, right? So the aim of this example of this class exercise we did was to determine the time standard in decimal minutes per unit, available minute per shift, effective minutes and takt time, and then conduct machine requirements for buying more machines and for implementation of overtime, right? What conclusion would you deduce from the results obtained in question 3? So this one, I'm sure you have an answer to this one as you covered this theoretically with your lecturer, right? So for our case, will be so bear in mind that you will get a theory question during your test, question similar to this, right? For this recording, we will be calculating, so we'll be answering questions 1 to 3, right? So you will always have a statement like this, informing you about what you need, informing you about a list of products that you need to manufacture in order to make a product. So in this case, they're saying the below table shows the material list needed to build a toy car. All the parts of the car are made of metal. Yeah, I need to fix this part of the lab guide because not all parts are made of metal. But okay, let us assume, right? So this car has 11 different manufactured parts. Thus 11 root sheets are required. It's not, let me see. Yeah, it's 11 root sheets. So 11 root sheets. Okay. This car has 11 different manufactured parts, thus 11 root sheets are required. Demand is 2,000 units. This is important per 8-hour shift, right? So allocable overtime is 4 hours. So if we can meet, if we can produce 2,000 units per 8-hour shift, we might resort to using overtime, and then the allocable overtime that we have is 4 hours, right? But most of the time it's not ideal, but most of the time it's important, right? Allocating overtime means more costs to the company, right? Yeah. So expected efficiency is 80% and allowed downtime is 10%, right? So most of the time, expect this value, this expected efficiency, it's based on historical information, right? So also it was evaluated that the downtime is 10%, right? So your machine breakdowns and your other breakdowns, they all account to a percentage of 10%, right? So below is a list of your materials, the description and the picture, right? I will also upload this this exercise and also the lab guide, right? So in a way, the lab guide will also be answering our question as we are doing here now, right? So you have your part numbers on your root sheet, you have part numbers, part name, and then quantity per box, right? And then we have this table, which you'll always get during your test, and this table you will be performing calculations. So you'll use this table to perform calculations, right? um, so summary of root sheets, so it's a summary of root sheets. And then you have in this row you have your part names, panel floor up until bumpers, and then you have time standard pieces per hour, right? Parts per unit. So for panel floor we have one, we need to make one. For side panels we need to make two. For door panels we need to make two. And then yeah, for bumpers we need to make two, right? I won't go through all of these parts per unit, right? So but what this means is that in order to make one complete car, you have to manufacture these parts, right? And then operations, we have cutting, drilling, molding, polishing, and painting, right? So yeah, time standard pieces per hour for cutting is 1850, and then for side panels is 2750, and so on and so on and so on, right? One thing you must note before I continue is that these operations, you need to show them when you are designing your layout on Draw IO. Remember that for your lab test one, you'll be using two softwares. You'll be using Excel, and you'll be using Draw IO, of which I'll also do a recording about it, and yeah, the important things you need to know about it, right? So yeah, just bear in mind that like you need to put all these operations on your layout when you're designing it, right? Okay, so as I said, we'll be focusing on answering these three questions, right? But just know you'll have a theory question. So without wasting much time, let us open Excel, and then copy this table into Excel, and then start answering our questions. Okay, so let me just copy that table into Excel, right? Okay, but I don't really advise this. Sometimes like it can get errors, right? So it's much, to be on the more accurate side, it's much more better to type everything out. I'm also gonna try to reduce the table so that like during a test you can have more time, right? But yeah, you can, don't get me wrong, you can copy that table, copy this table into Excel. But to be on the much safer side in terms of not getting errors when you're performing your formulas, I prefer that you type it out manually, right? So yes, I'm just gonna copy it out. I'm just gonna type out the whole table, right? Part name. But yeah, I'll give more detail as to why I'm saying that it's not really safe to copy and paste. But if you're comfortable and if you know how to do that, go ahead, copy and paste that table into your Excel, right? So I'm just gonna pause and then type out the date and then continue the recording so that it's not a long recording. Okay, so I'm done with manually typing out my data. So yeah, I advise this as it's also typing practice, right? So that you can get better with using a keyboard and being quicker, right, with typing. Yeah, so that's one other reason why I'm advising that you do that. You type out the information, right? Let me just remove borders here. Okay, let me just put borders at the bottom. So this is just for me here. bottom. Okay, for aesthetics, yeah, top border. Okay, this looks much better. So once you have your table like this, the one that's the same as in the question, you will now copy and paste. So when you are in Excel, it's much more safer to copy and paste. Copy and paste that, and then just click escape. And then what you'll just do is you'll just remove the values in here. So you just select all the values under operations, and then you just say clear contents, right? So one other thing to observe is that should you copy and paste data from Word into Excel, sometimes your numbers are indented to the left, and when you and Excel is going to take that as a text and not as a number, and that's a problem when you're using a formula, right? Say for example, let me type the name John. The name John stays on the left, and yeah, when text is indented on the left in Excel, and then let's type a number 20. The number 20 is indented on the right. So when you are performing what you call formulas, Excel will, and then you are putting numbers in that formula, Excel wants to, like, the number has to be indented on the right, otherwise Excel will not identify that as a number, and then you'll get errors, for example, or you might get incorrect values. So that's one thing you should note, right? And me typing out the information didn't take me even 10 minutes, right? So yeah, the more you practice, the more you even get faster with typing. So anyway, let's continue with our exercise. So here you're going to just change the title to time standard pieces. What the question is saying, time standard in decimal minutes per unit. So here we're going to just change to time standard pieces per decimal minutes. Per unit, right? Or let's just put it time standard in decimal minutes per unit. Okay, that sounds much better. Then you can just fit to the cell, and then let me just maybe change the color to blue, right? So how you compute this, first things first, you have to get hourly time, which is always 60 minutes. 60 minutes, and then you now have to find available hourly time. So let me just move these down. So hourly time is 60 minutes. Available hourly time, how you get that is by using a formula equals to 60 multiplied by that downtime, which is 10%, which is 0.1, and then you get 6 minutes, right? I'm mistaken here, so it's going to be 60 minus it's going to be okay, 04 minus 04 times 0.1, and then you get your available hourly minutes to be 54 minutes. But another way of doing it, we can just copy this. Another way of doing it is just by saying your hourly time equals to hourly time multiplied by 0.9. That is when you take away 100, that's 100 from 0.1, right? 100% from that 10%, which is 90%, and then you immediately get your available hourly time in 54 minutes. But yeah, I'll just use one that we calculated. I was just showing you multiple ways on finding it, right? Okay, so once you have your available hourly time, you'll come to the cell here, and then you will perform your calculation, right? So it will be equals to 1 divided by, so you'll go to this cell, you'll click on that, so it'll be 1 over B6 multiplied by the available hourly time, right? 05, and then you can perform absolute referencing by clicking F4, or introducing the $sign before the letter and after the letter, right? This is to say that you're going to be using this number for all your calculations, right? And it's just to save time. And you're going to click enter. Now when you are calculating your time standard in decimal minutes per unit, it is always best practice to round it off to 3 decimal places, and I'm going to also require you to round off to 3 decimal places. So how you reduce the number of decimals, you just come here under the number group, and then you click on decrease decimal, right? And then so yeah, this is now 3 decimal places. So with absolute referencing, you can just simply drag up until bumpers, and then you would have calculated your oh, I forgot, for this case we have to use an if function, right? If it's equals to, so that you do not get, as you can see here, let me just exit. As you can see here, your cell is the same as your available hourly time, which does not make sense, right? It shouldn't be that way. So I'll just say if 1 over B6 times 05 is equals to available time, we can also reference that, absolute reference that, then we are saying print 0 if that's the case. Otherwise, print out this very formula. You can say copy and then paste, then you can just close there, then you can click enter, and then let's just autofill again and see the changes. So yeah, where there was a 54, you just put like a 0 there. Okay, and then let us see if we can also drag down, right? Okay, so if we drag down, it also performs the same calculations as we did in the cutting operation, but let us double check that. So it says 1 over B7, and then yeah, B7 corresponds to this one, to 400, and then 1 over B7 times 05, which is our available hourly time. Okay, if it's close to 05, then print 0, otherwise print 1 over B7 times 05, I mean, excuse me. So yeah, as you can see, as you move along, the cells are changing, but those values that we have locked doesn't change. That is 05, right? And then you're done with your time standard in decimal minutes per unit. Okay, after that we have to answer number 2. Number 2 says use the data in this table to calculate the following: available minute per shift, effective minutes, and the takt time. So for our case, we have to calculate our takt time without overtime, right? Takt time is the plant rate, as you might know, right? Let me just put some borders. Let me see something. Okay, yeah. So initially you can start off by writing the data that you're given. So we're given demand of 2000 watt units, and I need to see like the units, guys. If I don't see that, you'll be penalized, right? So we are given demand, and then we are given the shift time to be 8 hours, but when doing takt time calculations, you should always convert your hours to minutes. So you'll multiply that by 60. It doesn't give us an output because it didn't put an equal sign. Equals to 8 times 60, 480 minutes. So in order to produce our 2000 units, we have to do that in 480 minutes, but that is not realistic. Why? Because we have downtime to account for. So downtime is 480 is equals to 480. So it takes into, so our downtime eats into your shift time. So 480 times sorry about that, times 0.1, which is 48 minutes, right? Then once you're done calculating that, you have to now calculate the available minutes per shift, or you can just say available time. It's the same thing, really. How you get that is equals to your shift time, which is 480 minus your downtime, and then you click enter, and then you find that your available time is 480 432 minutes. But also we have to take into account like things like your lunch breaks, maintenance, cleanup, and stuff like that, right? So that also eats into your time. So if you take all that into account, you'll now be left with effective minutes. So what effective minutes are? This is like the actual minutes, the realistic minutes that you will be using in order to meet your demand of 2000 units. So how you get that is by equating using equal sign, and then selecting on available minutes per shift, which is 432, and then you multiply that by the plant efficiency. I mentioned that earlier on. So plant efficiency, it's 0.8 or 80%. So if you click enter, we'll now get our effective minutes. So we have 345.6 minutes to produce our parts, right? Our products, right? So just in case you're skeptical, you can instead of putting 0.8, you can just put 80%. How you do that? Let me just show it another way of doing that. So it'll be equals to available minute per shift times 80%. If you do that, you'll get the same answer, right? 345.6. Okay. So once you're done with that, you have to now calculate your takt time, your plant rate. Takt time is equals to demand, actually no, it's effective minutes divided by demand. Tends to confuse me. You get 0.17. So the units for that, the units for that is minutes per unit. So every 0.1728 that is the time we need to manufacture each unit, right? And then can do that just to make everything just to see everything in the cell, right? You can auto fit. Anyway, now we have to compute the takt time when we are considering overtime, right? So I can just let me just copy and paste this, copy and paste, and then just re-edit this. So takt time with overtime. So there's just a slight difference, but the way you calculate is the same, right? So demand is 2000 units. Downtime, okay, shift time. So this is where the difference comes in with the shift time. So remember, without overtime, we're saying we only stick to that 8-hour shift, but with overtime, so excuse me about that. So with overtime, we now include that 4 hours into our shift, right? So it will be equals to 8 plus 4, then multiply all that by 60, and then you'll get your total shift time to be 720 minutes. So your downtime now will be equal to 720 multiplied by that 10%, 0.1, which is 72 minutes, just over an hour, right? And then you can just also copy these, copy paste here, right? Then escape. Then available minute per shift is equals to shift time minus downtime, and then you get 648 minutes, right? And then the effective time when considering our plant efficiency is equals to available minute per shift multiplied by 0.8. Then we get our effective minutes to be 518.4, and it makes sense that it's much bigger than the one without overtime, right? So your takt time will be equals to effective minutes divided by units. Then you'll get 0.2595 minutes per unit. Okay, let me just style this. Okay, so you would have been done with your takt time without and with overtime. I need to see both, but obviously that's if you're given a scenario whereby you have overtime to consider, right? Anyway, now lastly we have to compute the time requirements let me just check this. Okay, so now we have to calculate the time requirements without overtime. So how you do that is, let's just copy and paste this table, copy and paste this table, and then we can just clear these contents. Can clear these contents, right click and then clear contents. Okay, and then we can just rewrite this and say time requirements without overtime. Okay, and then let's just maybe put this also in bold, right? So you use the table that you calculated, the time standard in decimal minutes per unit, right? Okay, so how you do this is that you will use equal sign, and we'll use, so it'll be let me just double check something. Okay, so how you'll do that, it'll be equals to cutting for the panel floor divided by, be careful here, so since we're saying time requirements without overtime, you must always use the takt time, the appropriate takt time. So it'll be B18 divided by B30, that is the takt time without overtime, and then you will simply multiply that by your parts per unit, right? And then, so since we're using the same takt time for this table, you can also absolute reference it, and then you can click enter, and then you can autofill across, and then you can autofill going down. Okay, so we can't be getting all zeros, so let me just click undo and check my formula. E44, wait, E44, E44, okay, for cancel. So it's fine for this row, it's fine. So it means in this case we must just calculate for each cell, for each operation, and then we can drag across, right? So for cutting, for drilling, it will be equals to 0.135 divided by the takt time without overtime, multiplied by 1, right? Then click, okay, you can reference this, click enter, and you can drag across, and then you repeat the same thing for molding. This one will be 0, anything divided by 0, it's 0. But yeah, let's just follow the formula. Times 1, and then if you drag along, you get those values. So for polishing, it will be equals to B21 divided by the takt time without overtime, then absolute reference that, then multiply by 1. Okay, then you can drag across, right? Okay, actually, we're mistaken here. It's not really time requirements per se, but we can actually say it's your machine requirements without overtime. So this is us coming to the answering of the question of machine requirements, right? So yeah, we will know for each process how many machines we need, right? But yeah, I can foresee that for our entire operation is gonna need a lot of machines, right? But anyway, we'll talk about that in a few minutes. So for painting, it's equals to P22, which is 0.09 divided by take time multiplied by that parts per unit. Enter. Okay, let me see what we did wrong here. Okay, I forgot to reference this. Okay, then drag along and then you get those answers. So your total number of machines required. So we were calculating total number of machines required for our whole process, and then ideal number of machines. You'll know why, what we mean by ideal number of machines. Okay, so we can here for the total we can use the sum, equals the sum function, and then sum across, right, under cutting, and then close and then enter, right, and then we can just cancel. Okay, you can just drag down to find the total number of machines for the other processes, right? So if you can see this, the total number of machines, it's, for example, for cutting is 2.023, but there's no such thing as like a machine that has decimal. Like, it's like a human. You cannot say that we have 2.023 people, right? So now coming to the ideal number of machines, this is where we are actually rounding up to get an integer, yeah, to get a whole number, right? So we just say equals to, use the round up function, and then you click on the on the value, the first value under total number of machines, and then you have to also assign another argument, number of digits we're rounding off, it's 0, right, if you want the whole number. And then you can close parentheses, and then you can click enter. So the reason we're rounding up, it's because you never want to experience bottlenecks, right? So if you round down, you might find that your process is overwhelmed and you now have bottlenecks. There's no your workflow is not as efficient, right? So rounding up allows you to have that buffer machine, if I can put it like that, that can be used for maybe for cases that we do not plan for, right? So we can also drag down, and then we just remove the decimals. So yeah, so the total number of machines we need for the whole process, it's what, 3 plus 5 is 8, 8 plus 3 is 11, 11 plus 4 is 15, 15 plus 3 is 18. 18 number of machines for making of this car. And yeah, it is like that in industry, but yeah, this will mean that your layout will be big, right? But I'll also inform you that, like, if like a layout should be based on machine requirements without or with overtime, right? So yeah, just also keep that in mind. Be sure to read the question carefully, right? So yeah, now let us finally calculate the machine requirements with overtime. You can just simply copy all this and paste under, and then exit, and escape, and then we can clear these contents. I should have selected everything like that. So also clear contents here, right? So it's pretty much the same, but in this case we use this takt time, and we're saying takt time with overtime. Okay, so for cutting it will be equals to cutting divided by takt time. Then we can just reference that, multiply by that part per unit, then click enter. Okay, then you can drag across like that. Yeah, I don't see why you can't even drag up until this. Okay, no, you can't. Okay, and then for drilling is equals to okay, let me just double check something. Be sure that like when you're calculating this table, don't use this table, right? You don't use this table, you use this initial one, time standard in decimal minutes, time standard in decimal minutes per unit. So I just want to double check if I didn't use this value, but I'm sure I didn't. But let me just double check. B18. Okay, yeah, I used this value, right? Okay, from this table. Okay, so for drilling it will be equals to 0.135 divided by the stack time. Then you can reference that, and then multiply by this parts per unit. Then click enter. Then you can drag along like that. Then you repeat the same from molding up until painting. Equals to then lastly painting equals to 0.039 divided by 0.2592 for times, what am I doing, times parts per unit, and then enter. Okay, again click, drag along. Okay, oh yeah, the reason I couldn't drag to here is because we didn't have a formula defined. So it's equals to sum, then sum all these, and then enter, and then you can drag down. Then you can use the round up function. So I might ask, why do we round up? So I might ask you that. So you can just click this, and then the number of digits is 0, close parentheses, and then click enter, and then drag down. So from without doing much calculations, I can see that when your machine requirements with overtime, they're less compared to without overtime. But let me just double check that. So if you can select all of them, the sum here under your sheet, the sum says 18, right? Machines are required. So but for this one, you can see that we need 12 when we are using overtime, right? Interesting. Okay, and with that concludes our exercise. Okay, let's just say part 1 of this lab. So part 2, you're gonna be required, based on this question, to design a layout, right? So I'm just gonna take you through the software we'll be using for that. So we'll be using Draw.io. So Draw.io, you can get it on the website, and you can just type Draw.io like that, and then it will be the first thing you see once you have clicked enter. So you'll just click Draw.io there, and then you'll see this interface, flowchart make and online diagram software. So we'll be using Draw.io along with Layout IQ, but Layout IQ will cover that next week, right? So you get this interface whereby you can save your diagrams to either your OneDrive, your Google Drive, your device, Dropbox, GitHub, and etc. Right? But yeah, for this case, we can just say decide later, right? And then you'll get your workspace like this, and then on the top left there, you'll see untitled diagram. So your diagram doesn't have a title now. Your file doesn't have a title, right? And then you have your file, edit, view, arrange, extras, and help tools there. And then yeah, these are more tools for you. So explore them, but of which you won't use most of them. And then you can search for shapes. Actually, let's say triangle, and click enter. If I clicked enter, you see all these triangle, or yeah, some that are similar to triangle and so on, right? Yeah, you have a scratch pad. I don't know much about this. And then you have your general shapes, which you can put text within them. So yeah, but for us, we will be using, okay, you can use these, and then the other important ones that you need to use are your, if you can go to, if I remember, you go to more shapes, yes, and then you go to okay, so under other, you'll click floor plans, right? Once you've clicked floor plans, you'll just click apply, and then if you can scroll down, you would have added a new what's this folder, right? So if you click on this folder, it shows you the what's this, it shows you all the, should I say, yeah, all the components you'll need to draw your layout. For example, this is a wall. It's a it's vertical wall, and then this is a horizontal wall. This is a wall corner, southwest seems, and then there's a vertical dimension. So if you want to dimension your work, you can do that. But yeah, for this lab, no need to go into so much details. So you can have a room like this, and then you can have yeah, horizontal dimension, and then you have stairs. Yeah, I don't know how you'll be putting those stairs, but yeah, if you want to put stairs in your layout, there's a door, double door, revolving door, overhead, sliding glass door, flat TV, floor lamp, desk corner. Yeah, you can basically just explore all these different um, components here, right? So say you want to put like a machine and there isn't like that specific machine. First try searching it out. Let me just try this lathe machine, for example. So they are not really giving us what we're looking for. So if that's the case, you can just simply put like a square that symbolizes your machine, and then within that shape you can just double click in the middle of it and then just write lathe machine. Yeah, lathe machine, and then maybe also you can also maybe copy this and paste, and then under lathe, for example, it can be maybe cutting, for example, as we saw in one of our processes, and so on and so on and so on. And then we can put like, for example, say yeah, you put like a demarcation like this for your whole plant. So this is like the four walls of your plant, and then you can maybe have, for example, let me have an opening here. Okay, okay, let me just say I want to put like a receiving department and shipping department. Trying to find a better way. So yeah, you can have offices, and your offices can have a conference table like this in your layout. Let me just put it like this. You can obviously reduce that. Yeah, let me just delete this. So these are chairs, let me just select all of them like this, delete. So yeah, I'm just trying to show you how you can be creative, right? Yeah, but this one, it's sort of self-study. Just go. So this is I don't want to use this door. Let's use a sliding door. Sliding door. Yeah, sliding door like this. So let's just say our sliding door is here, for example. So this is where we receive our things, and then let me just also copy and paste, and then let's say here, after the whole process, this is our shipping. So we can go to yeah, you can just put it like this and then write shipping, for example. And then here, let me just copy, counter-side. So yeah, this, what I like about this software is that it aligns things nicely for you. So you can put here receiving department, and so on and so on and so on. And you can show and you can also rotate this. Okay, maybe this one is not the, let me see. Okay, not the best shape. I'm trying to see. Okay, Okay, I'm trying to find arrows. Let me see. Under arrows, for example, you can put such an arrow like this, and then at the top right corner you can see this rotating triangle, if I can put it like that, which is in an anti-clockwise direction. This just shows you that if you can click on it, you can rotate your shape however way you like it. So say after lathe machine we go to cutting, you can show it by an arrow like this to show which process follows which, right? And so on and so on and so on and so on, right? And then and then you have more processes, other departments. You'll just be creative about it. So I advise that you start practicing on it, right? And let me just see something. So we're in dark mode. It's not always in dark mode. You can put it view. I see. Full screen. I'm not finding where you can reset it. Okay, let's see reset view. Okay. So I think it's because my search engine is set to dark mode. If yours it's on default mode, your layout will be different to mine. It won't be this dark, it will be light, but yeah, same functionality, right? And then so you'll be submitting your Excel spreadsheet and your designed layout, and then and then we'll mark your layout, right? As long as it has the process operations and the number of machines that you calculated, you are good to go. But it must also have auxiliary departments. So I mentioned auxiliary departments. What are auxiliary departments? Those are your warehouse department, your tooling department, your offices perhaps. You can also research about auxiliary departments, but I'm sure ma'am went taught you about that, right? And then you'll have your nice layout, and then you can save it, and then for this case, since you'll be using this very same layout also in lab 2, you can save your layout during the test, that is, you can save your layout in your email, right? So that next time around you can easily retrieve it and then optimize that layout, right? I'll inform you in detail in our next sessions, right? In our session 2. All right, so that is it for this recording.